For this question, a graph of a function is shown to the right. Using that graph, find the following function values. That is, given the inputs, find the outputs. We have f of negative 14, f of 0, and f of negative 7. And the graph shown on the right is a linear graph. So what we need to pay attention to here is understanding the notation that we see. We have this notation, which is our function notation, f of negative 14, and the meaning of this notation is the value that we have inside the parentheses is our x value, and the output is the y value. So because we've been provided a graph with ordered pairs, there's no calculation needed. We would just read the graph looking for an x value of 14, and then we can record what the y value is at that point. So I'm going to look over here on my graph, and I'm looking for an x value of negative 14, which would be here. We want to get onto the graph. This point right here is on the graph, and it has an x coordinate of negative 14. And we can look over here to the y scale and record what that y coordinate is. So we know the ordered pair negative 14, 5 is on this graph. And that means that f of negative 14 is 5, the y coordinate at that x value of negative 14. We can do the same thing with the next one, f of 0. So 0 is the x, and x of 0 would be right here. We want to go to the graph and record what that y coordinate is. So that ordered pair has an x coordinate of 0 and a y coordinate of negative 5. So we have f of 0 equaling negative 5. The last one we have here is f of negative 7. Negative 7 is our x. We want to find an ordered pair on the graph with an x coordinate of negative 7. And that would be right here. That ordered pair is on the line. It has an x coordinate of negative 7. We can see that it has a y coordinate of 0. So f of negative 7 is 0. Given the quadratic function in vertex form, address the following. F of x is equal to negative 5 times x plus 2 squared plus 5. What are the coordinates of the vertex? This is the equation of a quadratic function in vertex form. So let's take a moment to think about what vertex form looks like. A function, a quadratic function that's in vertex form, will follow the pattern of a times x minus h squared plus k. And the vertex of that quadratic, or that parabola, will be the ordered pair hk. So you can see within the vertex form the values of h and k. For the example that we have f of x equaling negative 5 times x plus 2 squared plus 5. If we look at the vertex form, the h, which is the x coordinate of the vertex, follows the minus sign in that formula. Here's the minus sign in that formula, and our value of h, the x coordinate, follows that minus sign. In the example we have a plus sign. I'm going to rewrite this. Every addition can be written as subtraction in the following way. You could write x minus a negative And when you subtract a negative, that's the same thing as adding. So now I can see that the value following the minus sign is -2, and that's going to be h. -2 is the x-coordinate of the vertex. And then k is the y-coordinate of the vertex. That's the number that's either added or subtracted on the end here. And that's our value of k. Our k is 5. And we have the vertex of our quadratic being the ordered pair -2, 5. For our next part, we want to know, does the graph open up or open down? So once again, our function is in vertex form, which is f of x equals a times x minus h squared plus k. And in the vertex form, the coefficient a is going to tell us whether the graph opens up or opens down. So for our example, a is equal to -5. And when a is negative, when a is less than 0, the graph opens down. And when a is greater than 0 or positive, the graph opens up. Opens down means your parabola would be facing down like this or opening down. And opening up would look like this. So because our value of a is less than 0, we know that it opens down. And for the last question related to this function is, what is the equation of the axis of symmetry? Now when we have a parabola that either faces up or down, so here's an example of facing up or opening up, and here's one of opening down. These parabolas have symmetry around the vertex. So if we draw a vertical line passing through the vertex, we get what's called the axis of symmetry. And this symmetry means that we're going to have a mirror image on either side of that axis of symmetry, a mirror image around the vertex. So if we remember, our vertex is the ordered pair HK. And our axis of symmetry is a vertical line passing through that vertex. So we're going to be able to use the x-coordinate of the vertex to identify the axis of symmetry. From earlier, we found that the vertex was the ordered pair -2, 5. So our axis of symmetry is the vertical line x equals -2. On this question, we want to use the graph of y equals 2 to the x and the transformations to sketch the equation of the function f of x equals 2 to the x plus 6. We want to determine the domain and range, and also determine the y-intercept, and find the equation of the horizontal asymptote. Now the first part says we want to use the coordinates of the points on the graph of y equals 2 to the x. Those coordinates are given to us, but I want to go over where these coordinates come from. So if we have the equation y equals 2 to the x, we can find ordered pairs that are on this graph by plotting points. I can make a chart of x's and y's and choose x values and find the y's that go with those x values. You can choose a standard set of x's, -2, -1, 0, 1, and 2, and substitute those values into the equation to get those y coordinates. So that's 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 to the second power. We simplify these. 2 to the second power is 4, 2 to the first power is 2, 2 to the 0 power is 1, 2 to the -1 power. Having a negative in the exponent means reciprocal of that base. 2 is the base, -1 is the exponent. Having that negative means reciprocal of the base. Reciprocal of 2 is 1/2. We would still raise that to the first power, and 1/2 to the first power is 1/2. 2 to the -2, that negative still means reciprocal of the base. We're going to do the reciprocal of 2 is 1/2. Raise that to the second power, and we get 1/4. So this is our base function. We want to think about the graph of this base function. We can take those ordered pairs and plot them, -2 and 1/4, -1.5, 0, 1, 1, 2, and 2, 4. We get a graph that looks like this. And for later, it's important for us to know that there is a horizontal asymptote that is right on top of the x-axis, and that is the equation y equals 0. And you can see that the ordered pairs that are written down right here, -1, 1/2, match the ordered pairs that we figured out for ourselves, 0, 1, 1, 2. So these are ordered pairs that are on the graph of y equals 2 to the x. We want to find the corresponding points that match for this other equation, f of x equals 2 to the x plus 6. So we now want to know ordered pairs that are on the graph of f of x equals 2 to the x plus 6. We're going to use our knowledge about transformations. So the difference between our base equation, 2 to the x, and the function we're interested in, 2 to the x plus 6, is this plus 6 here. So we need to know what that transformation does to the graph. We know that when we have adding or subtracting, that creates a shift. And so we have adding 6, that's going to be a shift. Because that adding is inside of my base function, I know it is a horizontal shift. And because it's a plus, I know it's a shift left. And we're going to shift left 6 units. So if we take the ordered pairs here and shift those ordered pairs left 6 units, we'll arrive at the ordered pairs that are on our graph f of x equals 2 to the x plus 6. So let's take these points one at a time. The ordered pair -1 and 1/2, if I want to shift it left, you may have a hard time thinking of this in your head. So it might be helpful if you use your graph that we made earlier. So we have this point right here, which is -1 and 1/2. And we want to shift that left 6. If we shift that left 6, that means that we're going to arrive 1, 2, 3, 4, 5, 6 right here. And if we think about that ordered pair, you'll notice that the y coordinate did not change, only the x coordinate. So the x coordinate, we moved it 6. We subtracted 6 from it, and that gets me to an ordered pair of -7 1/2. We can do the same thing with the next coordinate of 0, 1. The y-coordinate will stay fixed. The x-coordinate gets shifted left 6. And we have the ordered pair -6, 1. If you have trouble doing this in your head, use the picture of the graph to help you. And then we have 1, 2. The y-coordinate will stay the same, and the x-coordinate, we subtract 6. It's a -5, -2. So we have our ordered pairs that are on the graph of 2 to the x plus 6. Let's answer the remaining questions. We want to determine the domain and range. In order to determine the domain and range, I'm going to plot these points so I know what that graph looks like. 1, 2, 3, 4, 5, 6, 7, and 1/2, -6, and 1, -5, and 2. We get a graph that looks like this. So for our domain, the domain is going to go from -infinity to infinity. So this portion of the graph, even though it keeps getting larger and larger, it also keeps moving to the right. And so it's going to cover every x value. The range, because of the asymptote, the range is going to start at 0, but 0 is not included. The graph never actually reaches the asymptote, it just keeps moving closer and closer. We want to determine the y-intercept. So to find a y-intercept, we're going to let x equal 0 for our function f of x equals 2 to the x plus 6. I'll substitute a 0 in for x, and that gives me 2 to the 0 plus 6. That's 2 to the 6th power, and 2 to the 6th power is equal to 64. So the ordered pair 0, 64 is the y-intercept. We also want to find the equation of the horizontal asymptote. I mentioned the horizontal asymptote earlier when we were graphing the base function. And remember the transformation that we made was to shift left 6 units. If we think about shifting the horizontal asymptote left 6 units, the horizontal asymptote still remains on top of the x-axis, which is y equals 0. So we have our horizontal asymptote being the equation of y equals 0. Thank you for checking out my videos. Have a great day.